projection presumes.
Okay, stereographic projection and mnemonic projection, yeah?
Okay.
So what is it? So you have a sphere, right? So this sort of comes under
3D
3D geo, yeah? And then you take a tangent. You take a tangent plane to the sphere, right?
Oh no, this is a great line. Is that like behind the sphere?
It's a tangent to the sphere.
Oh yeah.
It's a tangent.
We did this in complex analysis. The
What?
Riemann sphere.
Complex analysis.
Alright, okay, so maybe we can do the exercise next week or something. Maybe to be continued, yeah? So this is so cool. This is like one of the most sort of standard ways of. So if you take up. So if you take the point that is touching, right?
Mm-hmm. The tangent point.
Circles. Wait, circles.
And then you take its antipodal point, yeah?
Yes.
Okay. So the other side of the
Yeah.
Yeah.
Like
Yes.
So if you take this point and you draw a line to the plane, yeah?
Oh, it projects the point.
Yeah.
Oh,
It takes a point on the sphere.
True. Only 1 point.
Oh,
they only exist.
wait, I think
It's all lines.
there's two. It might be
No,
two. I
you
think there's
don't-
two
Oh,
versions.
yeah.
One is where
Yeah.
the plane passes through the center of the sphere, and then that's the one I saw. Plane goes through the center of the sphere.
Yeah, so that might be the mnemonic projection.
Oh, wait.
Okay, so what you do is you take this point, okay, and
Dang. Presumption.
so you remove this point here, right?
Yeah.
So every point on the sphere except for this point here,
Yeah.
right, is mapped onto a point on the plane.
And it maps to
Yeah.
circles, right?
So it's kind of like you're like wrapping the plane around
Yeah.
the sphere
Yeah.
and the hole at the top. Yeah.
Unraveling this sphere.
Unravel.
Yeah.
Unravel.
Yeah. So like
That is
so okay. And it sends circles to circles
Yes.
circles to circles.
and it sends spheres to spheres. No, it doesn't make sense. It sends spheres to spheres.
What else does
line
it
to line?
Huh?
Yeah, it does.
Line
You
to
would
line.
send line.
Oh,
Yeah, it sends lines to lines. Well, there's not
Arcs to
really
arcs.
any. Yeah. So the cool thing about and then there's another thing called mnemonic projection.
Wait,
Yeah.
what's a line? Wait, so
Like just a line between two
line.
circles. Oh, between two things on the sphere.
line on the sphere?
It's like
it's on a great circle.
Like a great circle is the biggest diameter circles, and then you have little circles, I guess.
Wait, a great circle's a line. I mean, a great circle has the line contains line segments.
Yeah.
So a diameter.
A line on a sphere.
Wait, I mean,
I guess it'd be like a part of a, because you would say like, you wouldn't say line anymore. You'd say like geodesic. So like, because it's not about the line being straight. It's more about the shortest distance between 2 points. So that it's like that you can make sense of
Wait,
a
is the
sphere.
shortest distance between two
Yeah.
points always a geodesic?
But like in space, a straight line is the shortest distance. So on the sphere, you wouldn't say line anymore. You'd say geodesic, and it'd be the
I
curved
think there's
line.
a problem because if you wrap the circle around, like if you draw, what does an entire great circle go to?
A circle
Oh.
would just go to the biggest circle.
Because
Yeah.
then a line.
But how do you even
when a
make
line
a
can't go to a
mnemonic
line?
projection? I don't understand.
Wait,
How
how
do
do
you
you
make
entire
it? But
great-
the circle is like not really a line. So how do you make it?
But
So an
but then
entire great
as line
yeah
segments. No wait.
yeah. So
Geodesic.
Oh,
Wait,
so the
problem is-
great circles that go through the missing point. So
wait,
the
that's weird.
so the great circles that go through the missing point, right? They're the ones that go to like
Oh, what about
Oh, those go to line.
those
what
go to
about a
lines.
circle that's like parallel to the plane?
Yeah, that'll go to a circle.
Oh, that
So-
makes so much more sense. You project
So
from the
geodesics
center.
actually. So geodesics are
Oh no,
definitely.
it's the distance is not actually parallel to the plane.
Geodesics go to arcs.
No.
Wait.
I think the law is like the distance between those 2 points isn't like this. It's more like that.
Oh, yeah.
It's like so like the arc you're taking, the geodesic distance is like not the same as the arc of the circle on the sphere. Wait a minute. They don't correspond to each other.
Oh, you
The
do
dis-
take
the
yeah.
shortest
The
distance
projection
is
from
like
the
not
sphere.
the same plane as the
The
parallel
tangent,
to
the
the
tangent,
plane of
yeah.
the.
The parallel, yeah.
It's kind of hard to imagine. But like,
I see what you mean.
let me get a ball.
The
Experiment.
geodesic is the
Oh,
great.
tomato. Alright, this is the point. This is the plane.
Yeah.
You have a circle like around.
Like if it's parallel, then
Yeah.
say.
This like the geodesic distance between like 2 points like here and here is not like this arc, but it's like closer to like this arc like that.
Oh yes.
So it's like not the same as projecting that onto the. Well, this line here does make a straight line. It's a straight.
So geodesics go lines or
Yeah, geodesic like
wait, but great circles go to circle.
yeah.
But then
The circle isn't necessarily like. It's not the
Wait,
same
that's
as
so
the lines.
massive,
Like,
brain.
like
So maybe
a line. Your
Oh,
definition
that's
of
such a
line
small
is-
way of constructing.
like the shortest distance between 2 points of the
Yeah.
sphere.
That's so a line is defined as a geodesic.
Yes.
But then wait,
Or like
the problem
a
I'm having
segment.
is the problem I'm having is the whole great circle goes to a circle, so that means a geodesic is an arc of the geodesic is an arc of a great
Yeah,
circle.
but
Yeah.
it can't be parallel.
Wow,
That
the international
doesn't mean it goes to
media
an arc of the
organization.
because an arc because the circle goes to circle, but then arc of circle has to go to arc of circle.
No, like not all arcs on the sphere are like geodesic. Like the shortest distance between those 2 points is not that arc parallel to the plane.
Or as in arc of great circle.
Arc of the great circle.
Wait, arc of great circle is the same as a geodesic. Arc of
Well, I'm saying it's like not the same. Like from here to here, this is your arc. The geodesic distance is like this line.
so that geodesic is an arc of the great circle.
Or like this circle.
Oh yeah, the arc of a great circle, but the great circle itself goes to another goes to a circle, but I mean arc of great circle goes to a circle. I mean arc of great circle has to go to arc of plane.
yeah.
Yeah.
I'm so can we do this? Can we like
Wait,
physically?
No, I think that circle would go to a line. Like
wait, great circles go to this.
Wow.
Okay,
Talking about
So great
stereographic-
circles which pass through the missing point go to lines, yeah, like a big
Thing
long
is-
line.
oh, I think
like
the
you-
arc has to be part of
Oh
the
wait,
circle.
but except for the one that's like.
Oh yeah.
What have we got?
Arcs of the same longitude.
Longitude.
Longitude, length.
Okay, maybe to make this work, we'll kind of skip the mnemonic projection part for now, yeah? Let me just tell you what the mnemonic projection is. So instead of starting at the end, you start at the middle of the sphere.
That's like closest to inversion.
Yeah.
Oh, wait, hold on. This is a key word here. So now instead of getting like 1 point of the sphere to the plane, you get a pair of points.
Yes.
Because like if you're coming from the
Oh,
center, you get the opposite poles, right?
Yeah.
So can't you consider like a hemisphere?
Yeah. So
Yeah, like-
this is let's talk about. So this we'll maybe do this next time, yeah.
Alright,
Okay, but I heard the word inversion.
To get the points
Inversion.
inside, to get the points on a plane inside the sphere, you need the bottom points.
Yeah. So I heard the word inversion, yeah.
Inversion.
So inversion is what I want to focus on. So basically, can you see that?
Oh, the circle. If it's
So basically, this picture corresponds to that plane, right?
Yeah.
That's like just a normal plane, right?
yeah.
When you wrap it around the sphere, right, and you add that 1 point,
Yeah.
you get what's called the inversive plane. So
Whoa.
when you do inversion, right, inversion is a function that goes
I
from
kind of see it.
it goes from like what's inversion a function from? It's like a function from like the plane minus the center of the circle, right,
Yeah.
Yeah.
to the plane minus the center of the circle.
Yes.
Is that right?
Oh.
What?
So the there's no inverse of the center of the circle,
Yeah.
right?
Yeah.
So you kind of artificially add a point called like a point at infinity, right?
Yeah. Yeah.
So that's it's its own like the center of the circle goes to that point, and that point goes to the center of the circle.
Oh.
Yeah.
Yeah. Okay, to make this even more sick, okay,
Oh.
consider
Oh, and you can see the infinity point.
so think of this. Consider a sphere, right?
Yes.
Oh, that makes so much sense.
Okay, and consider the
Oh.
sphere as a sphere of inversion. So 3D
Yeah.
inversion, okay?
Yeah. Okay.
But
3D
then don't
inversion.
you just like
So take the center.
So it's the same definition, yeah? It's the
What's
OP
in-
over OP prime equals
Yeah.
R squared, yeah?
Yeah. So what's
Okay.
inside goes to other
Okay.
side.
So this is kind of sick. Okay.
Oh.
So the claim is for 3D inversion,
Yes.
like the same results are true. So like spheres go to spheres,
Ooh.
Damn.
and planes
Oh,
and
no.
planes
Go to
Go to-
spheres.
Yeah, well, planes that don't go through the origin, right?
Go to spheres. That
Go
can
to
do that.
spheres that do
Planes-
go through the origin.
And then
Planes
planes that go through the
the
origin
origin
stays
go
set.
to planes.
Spheres go to
Wait,
spheres.
how do you like? So you take the 3D inversion,
Yeah.
and you take the 3D space
Yes.
as a plane, and you take the 4-dimensional. You take a 4-dimensional object, spherical object, tangent to the 3D plane,
Oh,
and then take the inversion from there.
yeah, you probably
Get
could.
a
Oh, that was
4D inversion.
Wait, we should investigate that at some point.
4D inversion.
Okay.
Oh,
So-
wait. If you project the 3D immersion one.
Yeah. So how do we prove this? Okay. So this is kind of cool. So basically, if you have like a plane, right?
Yeah.
Like this, yeah.
Yeah.
And you want to prove that, say, like this inverts into a sphere, right?
Yeah.
Well, what does it? If you take a cross section, right?
Yeah.
Then you know that a circle like this, right, inverts
Oh, it's just that line.
to a line on the
Oh my
plane,
God,
right?
Yeah.
Yeah.
Oh.
Okay. And the sick thing is
Oh.
that cross section is rotationally symmetric. So if you rotate about this axis, okay.
Oh. So you can create a sphere. Oh.
So if you
right.
rotate
Yeah,
about
yeah.
this axis,
You create a sphere, and then you create the whole
Yeah.
plane. Oh, very
It's
nice.
so awesome, right?
That's so
Yeah.
nice.
This is actually in Geometry Revisited, the last section. The very
Oh
last.
my God, the secret.
This is the last page of Geometry Revisited. It's literally like
I thought
going
that
to
book
three.
was too outdated. I questioned the book. And
It's
I
really
doubted.
Oh,
No,
okay.
I doubted the book.
So because if you rotate, the circle gets you the whole sphere, right?
Yeah, and the line gives you the whole
And the
plane.
line gives you the whole
Oh
plane,
my
and this
God.
sphere gives you
Yeah,
That's so everything works, and you can. So obviously, I'm not going through all the cases, right?
But yeah.
Okay, but check it out. Okay, what happens if you take this sphere, right?
Yeah.
Instead of taking that plane far away, make it the tangent plane, right?
Oh.
Yeah.
Oh.
Okay, and what's its inverse?
What is this
Like
tangent?
the sphere.
The sphere.
The sphere that just touches, right?
Internally tangent.
Oh.
So it's exactly this picture here.
Oh.
Oh!
Wait.
Wait, I think I'm
Oh.
Isn't that freaking awesome?
Oh,
damn.
It's funny. I've actually tried to live read that section maybe once or twice before, and I never understood what it was saying. And I was like, so okay, I'll just take a step back. I'll read it in my own time. That's what it was trying to say.
Oh.
Isn't that awesome?
Wow, dang, bro. Like,
That
can you
is-
invert it back or how's it like?
Yeah, it's
Yeah.
inverse.
So see, the center of this the sphere has no inverse, right?
Yes.
Oh!
Yeah.
Unless you consider the fourth time.
This man, his brain is big.
This galaxy,
His
bro.
galaxy brain.
Galaxy as in
Wait.
time and
Yeah,
space.
because galaxy's only in 3D. Galaxy's not big enough.
Time and space. Dude, galaxy.
Yes, galaxy plus fourth dimension.
Galaxy extension.
Yeah, like it's like, how do you get bigger than galaxy? Well, you can't just say something bigger in the same dimension. We need to.
It's the modern Galois theory. We extend things to the
That's
fourth
a
dimension.
mean.
God theory.
Galois theory to the fourth dimension.
Wait, so this times this equals constant. Is that what?
Yeah.
Yeah,
What?
Well,
and it must, right? Look at it.
wait, so this is
Beautiful.
this is a stereographic one.
Yeah, so stereographic projection is in 3D inversion.
Oh
no. How did I get fooled?
How did I get fooled?
I mean, a fool. I mean, how I was a fool for so long. I mean, like,
But it's kind of like,
like.
but I feel like I didn't really know about inversion when I was learning maths, but the stereographic projection came up a lot, right? And people always like, I don't know. You can imagine people be like, oh, they try to explain it to you by relating it to something else they assume you should already know. And it just got lost on me because I never knew that, right? Yeah, so That's pretty awesome.
I see you found on Marcus.
This is how people make maps.
Oh yeah, so that automatically proves, yeah, like for stereographic projections, circles go to circles, right?
Yeah.
So actually, what because you can always realize a circle is the intersection of spheres or with planes or planes, spheres with spheres, right? So you can prove like it preserves angles, for example, preserves angles. So this is what Yasser was saying. If you're making a map, right?
Yes.
What you're really trying to do is you're trying to get the Earth, which is a sphere, right? And you're trying to put it on a flat plane, right?
On a map.
That's what a map is, yeah?
Yeah.
A map.
So if you do stereographic projection,
Oh, no,
it'll preserve the angles between the lines.
Wait, yeah, why would it be infinite?
Wait, this sounds like
Infinite map.
It sounds like mobile or something.
Infinitely big remote.
yeah, so there's like a famous problem. There's no way to map the sphere properly onto the plane, right?
Yeah.
Until finite.
Oh, it means
Yeah.
the North Pole is pretty much infinitely
Well,
big.
not even on the plane. You have to remove the point on the sphere. You still lose a point in this. Yeah.
Minus one.
Wait, that's really
Yeah.
weird because I mean the North Pole. You have the North Pole is actually the North Pole is it's everything. It's the whole plane minus a circle. Is the North Pole. Hang on.
We should
Is
do
that
this
right?
experiment.
Wait, the North Pole is
poke a needle through it.
wait, the North Pole is the whole plane minus a circle.
Yeah. So it preserves the angles between. So like the shapes of the islands and stuff should look
A bit weird.
the same.
Yeah.
Oh.
Oh wait, yeah, that's true.
So if anyone's interested in this, you could look up the exercises in Geometry Revisited. I don't know if I have that.
Oh wait, it's one problem. Wait, I'm trying to think. One problem.
Measure theory.
I don't know. So the Geometry Revisited somewhere like 6.7. It's at the very end.
Yeah.
Maybe we could look at the exercises there. There's like 4 exercises or 5.
Yes, theory. 3D geo theory.
Okay.
Oh wait, Michael. How do you know that super randomly great distorted circles still go to circles?
Distorted stuff.
Wait, so you have a sphere, then you have a really distorted looking circle. That's still go to another circle. That's meant to go to another circle.
Yeah. So any circle in space goes to another circle in space, or a line. You know, like if you include the. Yeah. So 5 exercises, and
You think about 3D inversion things.
yeah. So maybe like a little bit of a preview of the mnemonic projection. So like this is a way of what's called compactifying the plane. So you're adding one point, and then you're turning it into a sphere, right? For some reason, adding a point makes it more finite. Adding a point makes it more finite than before.
Yeah.
Okay, and then another way to compactify the plane is to instead of adding a point, you add a circle.
Oh,
Or you add like
it's like
it's well not maybe not a circle, like you add a so there's a difference between inversive plane and projective plane, right?
Oh, because you add like a point at
proje-
infinity
yeah.
in every direction.
Yeah, so for projective plane you add a line at infinity.
yes.
Yeah. So it's related to the mnemonic projection because that's the thing that you miss on the sphere
Yeah.
when you're projecting.
So cool.
It's the great circle that's parallel to the plane. Like if you're going from the middle, if you're projecting from the middle of the sphere,
that makes so much sense.
right?
Oh, that's
Like if you're going from the middle of the sphere, then there's a plane that's parallel to the plane.
There's like the
So that circle is not going anywhere, right?
Yeah.
So that's the circle. That's the line of infinity.
Oh, but would you project around that circle? Wait.
Yeah.
Middle.
But we're gonna talk more about that next
Yeah.
time. But like, isn't that cool?
So the
3D inversion. So it's the next lesson, 4D inversion.
What we learned.
to the existence of the the altitudes. Wait, we do
Did I put it in
the altitudes of a
Oh,
tetrahedron.
no, it's gonna be